It's completely unpredictable. It will explode. No, it won't. Offer me a chance to go for that. The thing is, it might be tomorrow. It might be during this transmission, and it would shimmer like a second sun above. The James Webb Telescope has, as of late, distinguished an unforeseen 250% expansion in the splendor of Betelgeuse, the red star arranged at the shoulder of the Orion constellation. This whimsical behavior has touched off excitement for an intriguing show. Some propose the sudden increase in brightness could indicate that Betelgeuse is preparing to go supernova, yet the exact timing remains uncertain. Experts conjecture it could happen before long. Join us as we explore the depths of space and untangle the mysteries surrounding this divine giant. Betelgeuse has the potential to reshape how we understand the universe. Despite its name not being commonly known, you've probably appreciated its brilliance. A bright red glow shining at the shoulder of Orion, a prominent star grouping. Betelgeuse's significance is staggering. If placed at the heart of our solar system, its outer surface would extend beyond Jupiter's orbit. This giant star, easily perceptible, continues to enchant us. Unlike most stars, Betelgeuse changes in brightness over time. Due to its proximity to our system, it is classified as a semi-regular variable star, with its splendor fluctuating consistently, pushing toward a potential catastrophic collapse into a supernova explosion. Recently, Betelgeuse has become even more captivating due to remarkable changes in brightness. These changes include a significant surge on May 20, 2023, when experts observed a stunning 142% increase in brightness, followed by a later update showing a 150% increase. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, noted that Betelgeuse currently ranks as the seventh brightest star in the night sky, climbing 3 spots from its usual 10th position. From the southern hemisphere, Betelgeuse shines brightly in the evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights Betelgeuse's importance. It offers a rare opportunity to study the final stages of a massive star's life, providing valuable insights into red giants' behavior before they explode as supernovae. When Betelgeuse eventually explodes, it could become incredibly bright for about a week, possibly casting shadows at night. This prospect has both amateur stargazers and professional astronomers eagerly anticipating the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the Pajarito Astronomers and Cosmology Club, notes the enduring interest in Betelgeuse's brightness fluctuations, a phenomenon observed for centuries by various cultures. Currently, Betelgeuse's brightness cycle lasts around 130 days, significantly shorter than its typical 400-day cycle. These rapid changes provide astronomers with a unique chance to study this stellar phenomenon in detail, shedding light on the final stages of a star's life. The astonishing behavior of Betelgeuse began in 2019, when it violently ejected part of its outer atmosphere. These fluctuations in brightness are unusual for Betelgeuse, raising questions about whether it will explode into a supernova. According to a paper by Dupree and other researchers from Harvard and the University of California, Berkeley, it will take another 5 to 10 years for Betelgeuse to return to its normal 400-day brightness cycle. Since the Great Dimming, Betelgeuse has shown light and radial velocity behavior that has shifted. Despite its erratic behavior, Betelgeuse remains a massive red supergiant star undergoing the final stages of rapid evolution. As it burns through its fuel, the core will collapse under its immense mass, resulting in a supernova explosion that could outshine entire galaxies. The timing of this explosion is uncertain. As noted by Dr. Worf, a professor of astronomy at the University of Portsmouth, predicting supernova events remains challenging given the limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, steadily progressing through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon in its core, a process that takes thousands of years. Eventually, it will progress to fuse heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and potentially forming a black hole or a neutron star. While some speculate about Betelgeuse's imminent explosion, Historical records show it has been growing redder over the past few centuries, suggesting it could take significant time before it goes supernova. NASA estimates that Betelgeuse is not expected to explode for another 100,000 years, offering reassurance that its blast is unlikely to occur within our lifetimes. Despite the uncertainty, Betelgeuse's behavior continues to fascinate researchers and drive advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us to remain open to potential outcomes, even as we acknowledge the unlikely possibility of witnessing Betelgeuse's explosion within our lives. Keeping up with its changes may lead to further scientific breakthroughs, reminding us to maintain hope for new discoveries in the universe. It's crucial to understand that our observations of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old. Theoretically, Betelgeuse may have already exploded, and we wouldn't yet know about it. While this possibility exists, it is far from certain. History has shown that our assumptions in astronomy can be challenged. Before 1987, astronomers believed only red supergiants could undergo supernovae. However, that year, a massive blue star in another galaxy exploded, surprising the academic community. There is still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of stellar phenomena. Regardless of the absence of an imminent explosion, Betelgeuse's current behavior is captivating. Its oscillation between dimming and brightening reveals fascinating physics. The fact that stars pulse on human timescales is remarkable. While Betelgeuse is currently much brighter than expected based on its usual 400-day cycle, there is hope it will eventually return to this cycle. However, it is struggling to do so. Later observations suggest that Betelgeuse may be in a late stage or approaching the end of the core carbon-burning cycle. This stage involves the transformation of carbon into heavier components like oxygen and magnesium could signal significant changes in Betelgeuse. If this is indeed the case, researchers foresee a core collapse leading to a supernova explosion that could occur within a few decades. However, the exact timing of Betelgeuse's evolution remains challenging to determine, and uncertainties persist. The possibility of witnessing Betelgeuse's explosion remains unclear, as the carbon-burning phase can last up to 1,000 years. The study suggesting an imminent explosion has not yet been accepted for publication. Nonetheless, the potential for Betelgeuse to become a supernova is exciting. It would be an extraordinary event, visible even during the day for several days. When the event occurs, the initial signs of the supernova will be subtle but unmistakable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of stellar debris. Betelgeuse will gradually grow brighter in the night sky, potentially reaching peak brightness 10,000 to 100,000 times its normal luminosity within just a few weeks. This spectacle will astonish anyone lucky enough to witness it, marking a significant moment in cosmic history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, concentrated into a single point of light. Incredibly, this brightness would be visible during daylight, creating dramatic shadows at night. Predictions suggest it might be 15 to 20 times brighter than Venus, currently the second brightest object in the night sky. The display of Betelgeuse's explosion would linger in our view for around 100 days, captivating space enthusiasts and offering a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova wouldn't pose any threat to humanity, as it is still a considerable distance away. Optics and telescopes would allow us to observe the event for an extended period without harm. Such a dramatic event would not go unnoticed. Historically, supernovae were often interpreted as ominous signs, and Betelgeuse's end could inspire fascinating reactions worldwide. Astronomers believe it might reignite widespread interest in stargazing, awakening people to the wonders of the cosmos on a global scale. Betelgeuse isn't the only red supergiant in our universe. Others like Eta Carinae could explode before it does. On average, the Milky Way should witness a supernova every 50 years, but we haven't seen one in the past 400 years. However, remnants of past explosions indicate that we are overdue for a remarkable celestial event. Betelgeuse's history is rich with notable events, including the dramatic dimming in the fall of 2019. This sudden decrease in brightness puzzled astronomers and sparked speculation about a potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the reason for its dimming remained a mystery until further observations provided insights. Skywatchers can easily spot Betelgeuse from their backyards, providing valuable observations to scientists for a deeper understanding of the star and its dramatic changes. Researchers rely on observatories like the Hubble Space Telescope to monitor Betelgeuse's behavior. The fascination with Betelgeuse is not just about its potential to explode, but also about the incredible opportunity it presents for scientists to study the final stages of a massive star's life. Through ongoing observations of Betelgeuse and similar stars, researchers continue to advance their understanding of the universe and the forces shaping its development. Betelgeuse, the enormous red supergiant star in the Orion constellation, has long been a subject of interest for astronomers and skywatchers alike. Despite its relative proximity in cosmic terms, just 640 light-years from Earth, its evolution offers a window into the dramatic life cycle of massive stars. A red supergiant like Betelgeuse is in the final stages of stellar evolution, having exhausted the hydrogen in its core and transitioned to burning heavier elements. This phase of life is marked by dramatic changes in size, brightness, and behavior, all of which make Betelgeuse a key object of study. The stellar dynamics of Betelgeuse are particularly fascinating because of how massive stars behave as they approach the end of their lifetimes. Unlike smaller stars, which undergo relatively predictable stages, massive stars like Betelgeuse experience a more chaotic and violent evolution. This includes expanding to enormous sizes, shedding outer layers, and eventually collapsing under the immense pressure in their cores. The collapse triggers a supernova explosion, one of the most spectacular events in the universe. Understanding this process not only provides astronomers with insights into the future of other stars but also sheds light on the elements and energy produced in such cataclysmic events, which are crucial for understanding the formation of heavier elements in the universe. While Betelgeuse has been known to vary in brightness for a long time, its recent unusual changes in behavior have sparked renewed interest. Some scientists suggest that these fluctuations could indicate instability in the star's outer layers. As the core undergoes fusion processes, the outer shell may expand and contract, leading to changes in brightness. These variations could be more extreme in stars nearing the end of their lives. Researchers are examining whether Betelgeuse's erratic behavior signals an imminent core collapse, or if it simply reflects the complex internal dynamics of a dying star. Although supernovae are rare occurrences in our universe, when they do happen, they emit immense amounts of energy, temporarily outshining entire galaxies. The explosion of Betelgeuse would send shock waves through our solar system. Although it wouldn't pose any danger to Earth due to the star's distance from us, the energy produced by such an event would likely create a brief burst of radiation detectable even by instruments here on Earth. This energy would not only illuminate the night sky for weeks or months, but also provide a unique opportunity for astronomers to study the aftermath of a stellar death in real time. As Betelgeuse continues its unpredictable behavior, scientists are using advanced technology to monitor and analyze its fluctuations. The James Webb Space Telescope, JWST, for example, offers a closer look at the star's atmosphere, helping researchers track potential changes in its composition. Other instruments, such as the Very Large Telescope, VLT, in Chile, are also playing a crucial role in providing high-resolution images of the star's changing dynamics. These observations are vital not only for understanding Betelgeuse itself but also for gaining insights into the behavior of similar stars further along in their evolutionary process. Despite the scientific excitement, the potential explosion of Betelgeuse has captivated the public imagination. Witnessing a star-go supernova within our lifetime is a rare possibility. While it's difficult to predict exactly when this might happen, the phenomenon is so extraordinary that it has drawn the attention of amateur astronomers and enthusiasts worldwide. Many eagerly await the chance to observe such an event, with some even hoping that advancements in astronomy could allow for better predictions in the future. The interest in Betelgeuse's looming fate.